The interstellar enigma, Comet 3I Atlas and its journey through our solar system. In the vast expanse of the cosmos, where stars ignite and fade over billions of years, rare interstellar visitors from distant stellar systems occasionally grace our solar neighborhood, offering glimpses into the origins of alien worlds. On July 1, 2025, astronomers using the Asteroid Terrestrial Impact Last Alert System, ATLAS in Chile, discovered one such wanderer, Comet 3I Atlas, the third confirmed interstellar object to visit our solar system, following 1I Oumuamua in 2017 and 2I Borisov in 2019. This Manhattan-sized icy giant has captivated scientists and the public with its immense size, extraordinary speed, peculiar composition, and a series of anomalies that challenge conventional cometary models. As of September 13, 2025, it races through the inner solar system at over 200,000 kilometers per hour, approaching its closest point to the Sun, perihelion, on October 29, 2025, at approximately 1.36 astronomical units, AU, just inside Mars's orbit. This essay provides a comprehensive exploration of Comet 3I Atlas, detailing its discovery, trajectory, physical properties, and scientific significance. Drawing on observations from major observatories like NASA's Hubble Space Telescope, James Webb Space Telescope, JWST, SPHEREx, and the Transiting Exoplanet Survey Satellite, TESS, as well as ground-based facilities such as Gemini South and the Very Large Telescope, VLT, we analyze its potential origins, unusual chemical makeup, and the debates surrounding its nature, natural or speculative artificial. We also examine public reactions on platforms like X, where fascination blends with speculation, and compare 3I/Atlas to its interstellar predecessors. Through detailed analysis and examples, this essay highlights how 3I Atlas enriches our understanding of exoplanetary systems and underscores the interdisciplinary allure of modern astronomy. Discovery and initial observations. The discovery of 3I Atlas began with its detection by the Atlas Survey, a NASA-funded program designed to spot near-Earth asteroids, but adept at identifying faint, distant objects. Initially appearing as a dim speck with a magnitude of about 18, barely visible to amateur telescopes, its hyperbolic trajectory quickly revealed its interstellar origins. Earlier images from the Zwicky Transient Facility and the Vera C. Rubin Observatory extended the observational timeline, confirming an unbound orbit that sets it apart from solar system objects. Early observations noted a fuzzy coma, a gaseous envelope around the nucleus, indicating cometary activity even at 6 AU from the Sun, where solar heating is minimal. This early outgassing, unlike typical comets, suggests a nucleus rich in volatiles, possibly altered by cosmic radiation during its long interstellar journey. For comparison, 2I Borisov began outgassing at around 3 AU, releasing carbon monoxide and water, while 3I Atlas's activity hints at a unique composition or history. Hubble's first clear image in July 2025 showed a teardrop-shaped dust cocoon around a nucleus estimated at 10 to 20 kilometers in diameter, larger than Oumuamua, 100-200 meters, but comparable to Borisov, about 1 kilometer. This size implies a massive object, potentially 1 million times heavier than Borisov, raising questions about its ability to withstand solar stresses as it nears perihelion. Trajectory and origin, a wanderer from the galactic thick disk. The path of 3I Atlas through our solar system is nearly linear, tilted at a steep angle to the ecliptic plane, aligning closely with the orbits of Venus, Mars, and Jupiter. Entering from the constellation Pegasus, it will pass within 0.19 AU of Mars on October 3, 2025, 0.36 AU of Venus in March 2026, and then Jupiter before exiting the solar system. Its hyperbolic velocity, far exceeding that of its predecessors, suggests an ancient object, possibly 3 to 11 billion years old, older than our solar system itself. To contextualize its unique trajectory, 3I Atlas has an orbital eccentricity of 6.143 and an inbound velocity of 60 km/s, compared to Oumuamua's eccentricity of 1.2 and velocity of 26 km with a perihelion of 0.25 AU, likely originating from a young system in the galactic thin disk. Similarly, 2I Borisov, with an eccentricity of 3.4, velocity of 32 km/h, and perihelion of 2.0 AU, is thought to have been ejected from a red dwarf protoplanetary disk. In contrast, 3I Atlas's extreme trajectory points to an origin in the Milky Way's thick disk, a region of older stars comprising about 15% of the galaxy's stellar mass, suggesting formation in a high radiation environment that altered its volatile content over billions of years. Astronomers propose that 3I Atlas was flung from its parent star through gravitational interactions in a protoplanetary disk. Backtracking its path over millions of years reveals potential encounters with other stars, which could have launched it into interstellar space. This ancient origin distinguishes it from its younger interstellar counterparts, offering a rare glimpse into the early galaxy. Physical characteristics and composition, a carbon dioxide conundrum. Observations from JWST in August 2025 revealed a coma dominated by carbon dioxide, CO2, with surprisingly little water, H2O, despite the comet being just beyond the water ice line at 2.5 AU. SPHEREx measurements confirmed a CO2 mass loss rate of about 70 kilos per second, with water emissions below detectable limits. This high CO2 to H2O ratio is unprecedented among comets, suggesting either formation near the CO2 ice line in its parent system or significant erosion of lighter ices during its interstellar voyage. Images from Gemini South in late August showed a developing tail, about 1/120th of a degree long, and a glowing coma shifting from reddish to green-blue hues, indicating the presence of cyanide, CN, and nickel emissions. The detection of nickel without iron, a rare trait in natural comets, evokes industrial processes, such as those used in metal plating. Enhanced VLT observations revealed spectral rays in blue, CO2 and CN, green, nickel, and red, CN and HCN, resembling structured plasma jets rather than typical cometary outgassing. Hubble's data noted a sunward glow elongated 10 times longer than wide, defying models of radiation pressure and unusual polarization unlike any known comet. Some analyses suggest a resonant plasma bubble around a self-luminous core, with directional emissions that challenge conventional cometary behavior. Recent updates and anomalies defying expectations. As of September 2025, 3I Atlas continues to evolve. TESS observations confirmed outgassing at 6 AU, linked to its CO2 richness. The comet's brightness has reached magnitude 13.9, with a diffuse coma and a tail extending nearly 2 arc minutes. Notable anomalies include non-gravitational acceleration without visible outgassing, a forward-directed headlight glow, and possible radio emissions. Some researchers highlight peculiarities. The comet's retrograde orbit aligns improbably with the ecliptic, a 1 in 500 chance, its massive size, an anti-tail, dust appearing to trail toward the sun, a CO2 nickel plume, and unique polarization. These traits have fueled speculation about exotic propulsion mechanisms or even artificial origins, though mainstream science attributes them to natural processes in an extreme cometary body. Scientific analysis and debates, natural or something more. Most astronomers view 3I Atlas as a natural comet, albeit an outlier. Its CO2 dominance may reflect formation in a radiation-intense disk, unlike water-rich solar system comets like Hale-Bopp. Its estimated age suggests it carries pristine material from the early galaxy, offering insights into ancient astrochemistry. However, the anomalies, particularly the structured emissions and non-gravitational motion, prompt some to consider techno-signatures, such as radio pulses, akin to those emitted by human probes like Voyager, no interstellar themselves. Critics argue that these traits fit models of dynamically old comets, shaped by billions of years of cosmic interactions. Yet, the possibility of artificial origins, while speculative, remains a valid avenue for investigation, especially as observatories continue to probe for unusual signals. Public reaction and speculations, science meets imagination. On platforms like X3I Atlas has ignited a firestorm of curiosity and conjecture. Posts range from awe at its green glow to wild theories linking it to biblical prophecies like wormwood or extraterrestrial probes. Some users claim it exhibits behaviors suggesting an active mechanism, while others tie it to unrelated phenomena like Jupiter's atmospheric changes or cryptocurrency tokens named Atlas. More grounded discussions focus on its scientific value, emphasizing the need for open data and continued observation. Future observations and implications. The upcoming Mars Flyby on October 3, 2025, offers a chance for ESA's Mars Express to capture images, potentially revealing the comet's shape, whether elongated, spherical, or irregular. Further observations by Hubble in November and JWST in December will probe its gaseous emissions, possibly clarifying its anomalies. If these peculiarities persist, 3I Atlas could redefine how we classify comets and interstellar objects. Its chemical profile provides a window into the conditions of distant stellar disks, aiding models of planet formation and habitability. With observatories like the Vera C. Rubin poised to detect more interstellar visitors, 3I Atlas marks the dawn of a new era in studying cosmic wanderers. Conclusion. Comet 3E Atlas is a celestial enigma, ancient, mysterious, and profoundly revealing. From its origins in the Milky Way's thick disk to its CO2-rich anomalies, it challenges our understanding while sparking wonder. As it speeds toward its exit from our solar system, it leaves behind a legacy, a reminder that our cosmic backyard is part of a larger galactic tapestry, with more interstellar stories yet to unfold.